So,
Is it not
notice I
recording?
put a tiny bit of 6-1 on here because there's a little teeny bit that our book does with the slope fields section that I just thought it's worth covering. So the 6-1, which is just entitled slope fields and Euler's method. Euler's method we do in BC. Kyle, you with us? Okay. If y equals e to the negative 2x, it says verify the solution of the differential equation. So if the differential equation was 3y prime plus 5y equals negative e to the negative 2x, verify that this is a solution. All this is a test in is your ability to plug and chug. This thing has a y. What are we going to replace this y with?
E raised to the negative 2.
E raised to the negative 2x. What are we going to replace that y prime with?
Negative 2e to the negative 2.
Well, figure out what y prime is. Negative 2e to the negative 2x. Negative 2e to the negative 2x.
And take out an E.
And see if they are the same.
There.
This is a negative 6e to the negative 2x plus
Negative 2.
No, it works out.
negative 6 plus 5 is negative 1.
And the exponent for the second one. Yeah, there it is.
So our proof is done.
That's it.
That's all we're doing.
That's easy.
That's why I thought I can at least show you this. But if they ever tell you to show that or prove that, let's do one a little bit weirder one. How about the differential equation is y double prime plus 4y prime equals 2e to the x. And the solution y equals 2/5 e to the negative 4x plus e to the x. So what are we going to need on this one?
The double derivative.
Yeah, the first derivative keeps that 2/5, right? What goes inside?
Negative 4 e to negative 4x plus e to the x.
Everybody good with that? What about y double prime?
2/5.
See, that 2/5 is good, just stay in there, right?
16 negative 4x.
Negative 4x.
Plus e to the x.
So then it's just a matter of, we've shown these derivatives, right? Plug and chug. 2/5, 16 e to the negative 4x plus e to the x, oops, plus 4 times 2/5 times negative 4 e to the negative 4x plus e to the x. I'm just going to work on the left side anyway.
Well, you can do that 4 times.
I mean, I guess we can distribute 32/5 e to the negative 4x plus 2/5 e to the x.
Minus 32 e to the negative
2 times 4 is 16. Minus 32 over 5 e to the negative 4x plus what? The 8/5. 4 times,
It'll be 8/5. Oh, yeah.
yeah, 8/5 e to the x.
I didn't see the 4.
And they do cancel. 8/5 plus 2/5 is 10/5, which is 2 e to the x, which was exactly what they wanted us to get, right? Proof done. So this proof is almost like those trig,
Why do you find the second derivative for that one and not the first one?
because, well, we found the first derivative before but it's because the differential equation had a y double prime in it.
Okay.
That's why we had to go to the second derivative. Up here, we didn't have to because there was no second derivative in our differential equation. And by the way, we haven't really defined what a differential equation is, but it's just an equation that has some derivatives in it, right?
So it'll give you the differential equation?
Yes.
Oh, okay.
Consider a
I
function.
thought you had to find it.
Not really. It's just an equation relating variables and derivatives. Now, the cool part about the 6-2 section is that we are already familiar with everything in here. The only thing is I'm bringing in the calculus. If a population or a population's growth rate of growth, whatever, growth rate is proportional to the population itself, then first of all, give a differential equation, and then 2, give a general solution. So, the population's growth rate of growth, that is, if we're going to call the population Y, what is the rate of growth of Y with respect to time? D. With respect to time, it would be dt, right? The rate of growth, dy dt, is proportional. That means there's a constant of proportionality, right? To the population itself. Well, if y is my population, then that is the differential equation. Done. It is the rate of growth of that population over time, right?
Why would I need y function of t?
Oh, you could say y of t. We just usually call it y. Y is a function of time, right? Now, give a general solution. Guys, the general solution we used over and over again last year.
It's like n plus 1 or a gap thing or a different thing.
No, y'all are going to recognize it. I want us to actually solve this differential equation, and this is going to be the process we solve all differential equations coming up, and there might even be a few easy ones here at the beginning. There are. So let's just do practicing what we call separating the variables. Separate the variables. In other words, get all y's on one side and anything with t's on the other. Well, the y over here, how would I take it to the left? Divide. How would I get the t part to the other side? Multiply by dt, right? So I divided by y, and I multiplied by dt. That k is just a constant. I could take it down here with the y. I choose to keep it with the t. So this is sufficiently separated. Remember, k is just some constant of proportionality, right? So it's not a variable, even though we think it looks like one. It is a constant for that particular population. Does that make sense? So now we can integrate both sides. Anybody know what the integral of dy over y is? Which is ln absolute value of y. K is just that constant, kt plus some constant, right? Now, how do I actually solve for a y if it's in an ln? What do you do to both sides? Anybody?
Oh, so something.
It is eating them.
Yeah.
E both sides. E to the ln of something is just that something, isn't it?
Oh, yeah.
Now, I do see an absolute value of y, and there could be the idea of a plus minus thing, but if I think of this, e to the c is just another constant. In fact, I'm going to call it c1 and just say that's some other constant times e to the kt. And now that absolute value part could be taken care of like with a positive or negative c, okay? So c takes care of the absolute value part. And by the way, if the time is 0, what is the c? It's a c times. Addition of powers turns into multiplication of like bases. I'm saying let capital C equal. C happens to be the initial value. Does anybody?
What?
Y equals y naught e to the. Does anybody have a recollection of that from last year?
I remember yoked.
Yoked. I do remember yoked.
Is that
I
the
never
K?
did yote. We did pert, but
Oh, I'm thinking of first.
you know.
I'm thinking, I don't know, yoked is
Yoked.
Is that the K function or the negative yoked?
This is the solution to any single exponential growth or decay problem you ever have. K is the rate of growth, right? For that particular population, right? So, you know, all of the problems today are, you know, applications of what you did last year. If you had, compounded, do y'all remember the compounded continuously? Yeah, that's A equals P e to the RT. So if I have a compounded continuous problem, it is exponential growth, right? If I have a half-life problem, it is an exponential decay, and my K is just negative, right? So everything we do is just like we did last year. If I had carbon 12, the half-life of carbon 12, or is that 14? I can't read.
I think it's 14.
Oh, they list both of them. They list all of them, but
It's 14.
it's 14. Yeah, I've seen them use all kinds. Half-life is 5,715 years. Let's do problem 36. 3 grams. 5,715 years. We need an initial quantity. We need the amount after 1,000 years and the amount after 10,000 years. In this problem, they give us the amount after 10,000 years, 3 grams. So we need to know the initial amount and the amount after 10,000 years. Well, what I always do, or what do we do to find the K if we're given a half-life? We said if we started out with 1, we end with a half, right? E to the K times 5,715 years, right? Take the ln of both sides.
The exponent becomes a coefficient.
5715K. So the K is just ln of 1/2 over 5715. Ln of 1/2 is ln of 2 to the negative 1. We could, if we don't want to have a fraction, make it negative ln of 2 over 5715. Both of these are the same, right? So then we're just gonna take our amount after 10,000 years. We don't know the initial value, but we want it, right? E to the K, whichever version we choose. And the T was 10,000. Who wants to plug and chug?
Is T always in use?
No. But you use whatever amount. Like in terms of bacteria, it grows in seconds or in hours.
So it'll be, so
You know,
the T,
will be
everything relative to the
consistent.
problem, it'll be-
It will be consistent, yes. So who can plug and chug that one? Well, we're gonna say 3 divided by all that mess,
We have
right?
a calculator we can use, right?
Yes, absolutely,
Three divided by all that thing?
yes.
Oh, yeah.
By the way, all of this is in the power, if you couldn't really tell. This is E to all that mess. All right, everything I keep reading about the coronavirus, don't touch your face. My eyes have been itching. All of this stuff blooming.
I just remember they were offering like $7,000 if you get infected and they can study you.
Really?
Yeah, you have to be over 18, I'm sure though. I mean, I'd do it. I don't care. $7,000. I mean,
I got 10.8.
My fear was like
10.09.
before I came down with it. It wasn't. I don't think I had the coronavirus at all, but before I got sick on Sunday morning when my fever
I
was
got
102,
.099.
I was with my mom all afternoon Saturday, and you know she's 82,
Yeah.
so I'm like,
I got .099.
so
yeah. So y'all want to be super careful, and my mom doesn't have any underlying health issues at all. I mean, she broke her hip. She has osteoporosis. That's her only issue. So she has.
$7,000, I think.
Wait, I got
I
10.09.
mean, it's like a
Did you get,
99%.
Michael, did you get 10.09?
10.09, yeah.
For our age, yeah.
10.09 what?
99.7.
Oh, 10.0892.
Remember, for calculus,
Yeah.
don't go into the AP exam and only round to 2 places, because that's what you do for physics. 3 places at least. Hey, just write down all the decimals you see, because what if you might need that number later? Just write them all
You
down.
just go. I just go up in my and then you hit enter.
Or you hit clear.
That's what we all do for physics. We
But you know, the issue is go up one more to the calculation, because when you go up and just grab that number, it actually stops where it stopped on the calculator. But if you go up to the calculation, it stores the infinite amount of decimals in there.
Oh, so you get
The
different
thing is that I
numbers.
have to plug in the, like, I have
Alright.
to plug in the calculation for the X.
So guys, after we found the why not, we'd again go back to the initial problem, you know, y equals that 10.089. Hey guys, hit store and store it in for some letter, right? Call it A.
Yeah.
And just put A, E to the, we could in fact store that one in for K, right?
I need to store things more.
Store is great.
Yeah, I never used it.
On the AP
Why
exam,
would
on
you
the
never use
calculator, store is awesome.
Yeah, store's the best.
So store what you need, store the A, store the K, and plug in the 1000 for the T.
I use store when chemistry, like when we were doing the early stuff, I like type it for like C, I type in the value for carbon and like all that stuff. When I was taking the test. It made it so
Has
much
anybody
easier.
plugged it?
It made it so much
Hunter, are
easier.
you plugging and chugging for us?
Yeah, but I'm getting errors, so something's not.
Did you get the 10.08? All right, show me your calculator. Let's see what's going on.
It doesn't matter. You should be in
Radians,
mode,
it won't matter
but you should be in mode.
unless
You're in scientific
if
mode.
you're using a trig function. That's the only time the mode radian or whatever.
You're in
it matters.
scientific mode. It just wants to. Or you're using an engineering calculator. Forgot this has an engineering mode on it. There's an engineering mode on the calculator.
What's that do?
I genuinely have no idea. It just does my engineering paper for me. That's what it does.
There's a lot of money in it.
Do y'all think pollen has started like just going crazy?
Yes.
Okay.
Like, 'cause
I'm not going
when
crazy.
pollen starts, I get a slight cough, and now I'm getting that.
But you know, I was watching the news and they said pollen count is 0. I'm like,
That's not
you've
right.
gotta be wrong, dude.
It's probably the way they calculate it. It's probably like parts per thousand and not parts per million. Yeah, it's probably, and also where they're testing.
All right, has anybody calculated it? Hand me your calculator. It's okay.
Really dumb.
Everybody learns from mistakes. It's all right.
I like what you did there.
All right, so we're saying 3 divided by
I did the 3 after.
parentheses e to the
But you said yours.
negative ln of 2
I wanted to, so I understood.
times
I need help.
10,000
That's such a
divided by
It is. I know. I didn't fall asleep. I was like, I don't know.
How do you not fall asleep? The first time I watched Moana, I fell asleep because it was on the trip back from Orlando 2 years
all
ago.
right. So guys, this was the number we're storing in for A, right?
Were you going? Universal's cheaper. That's why.
So A
No, it's not.
times
No, it isn't. The roller coasters are like the better, and they have slightly better rides, but Disney's way
Times.
cleaner. Disney's way cleaner and has like more rides.
e to the
I don't care.
negative
Universal
ln of
Universal has better
2.
rides.
Universal doesn't have Space Mountain. End of story.
Disney is overhyped.
It is overhyped. They're like really similar. I still think Disney's better. That's just because there's like a certain.
I've never been to Universal.
Okay.
Whoa. Hey, I got an error that time.
Okay. When you walk into Disney, there's like
It's because you have a
Charlotte.
giant
Charlotte. There's a feeling you get when you walk into Disney that you don't get it.
Oh.
No.
Tell me I'm wrong.
No,
I
it's the same
definitely.
feeling at every
Oh, hooey.
That was the first time I went to Disney.
I've done the whole Disney thing. It's fine.
Yeah,
There's no good rides.
All right, there it is.
Except for that one.
8.37.
I didn't like the rides at Universal, but
It's definitely more kiddish. All the rides are kids.
The only rides that I like
All right.
Disney are Space Mountain. Space
But it's
Mountain.
really cute.
For what? Disney?
Yeah.
It's not all meant for kids, for little ones.
oh no.
Oh, there's some good ones.
The only
But-
good rides at Disney are if they're not at Ascot.
Everest is
Special
good.
Mountain or Splash Mountain, Space
Everest
Mountain, and
and
Everest.
Space Mountain.
All right.
Space Mountain's my favorite.
Splash Mountain.
Splash Mountain's have like over. You can find Splash Mountain.
Guys, just to review, I'm going to give you a couple of the problems. Just to review, this is interest compounded continuously. Does anybody
Rock and roller coaster.
remember the other one? Please stop talking about Disney. 1 plus r over n raised to the nt. So compounded quarterly, Noah, means what? N is what?
Sorry.
Compounded quarterly means n is what?
I have no idea. 1.
Number of times per year.
Oh yeah.
So quarterly means
16.
4 times per year. What about monthly? 12 times per year.
24.
Bi-monthly would be 24.
Get my bi-monthly
How about
check.
daily?
365
365,
or
right?
366. 365.25. Well, what if it's 1.20? Oh, hold on.
All right.
Butcher's dead.
Do you have any medical social life?
Yeah.
1 through 13.
That's it? I
No.
was gonna say.
Man, can we just do
I just thought I just literally just rewatched. I never even seen
Yes. I'm not gonna shift the evenings, so I
Parks and Rec isn't great.
Parks and
after-
Rec is better.
No, it's
It's
definitely
not better
not.
at the end.
It's
The end
definitely-
season
You
sucks.
say it's
The last season was terrible.
Parks and
Compared to
Rec
The
is not
Office,
better
it's
than The
than
Office.
no, it's not.
No.
Top coffee.
No.
Stop.
It
No.
really is.
No, it's
The
not.
only part that's
You have no
better
opinion.
is like Ron. He's the only routine.
Ron is the
character.
only reason that Parks and Rec is entertaining.
Correct.
Andy's
It's
character-
only
Right,
Ron.
you're doomed. Yeah.
Oh my goodness, I've gotta stop this.
Charlotte is biased.
This is